Hi, I'm Jeremy.
I'm Alexa.
I'm Zena.
And today we're reporting from Dr. Fernand's class.
Today we're going to be talking about Coulomb's law and periodic trends.
CFCC, over and out.
Hello, I'm here with 18th century French physicist Augustin de Coulomb. And today we're going to be talking about Coulomb's law.
The equation for Coulomb's law, F equals K times Q1 times Q2 over D squared, clearly shows that as D increases, the force goes down, and as the charges Q1 and Q2 increase, the force goes up. The electron shell model is defined as the method in which atoms are organized, with a nucleus at the center and electron orbitals building outwards.
The outer shell holds electrons called valence electrons, which are used for bonding.
Hi, I'm Zena. I'm reporting live from Antarctica, where today we'll be talking about ionization energy.
First, ionization energy is the energy required to completely remove an electron from a neutral atom. Second, ionization energy is the energy required to completely remove a second electron from a neutral atom. Third, ionization energy is the energy required to completely remove a third electron from a neutral atom.
As the number of protons per electron increases, the inward pull on the electrons increases, which means it takes more energy to pull off an electron. As you go down a group, the number of shells increase, and this means that the distance increases, so the force decreases, so it's easier to remove an electron.
Hi, my name is Jeremy Glick. I'm here in sunny New Zealand to give you a special science edition of our newscast on atomic radius. Atomic radius is the measure of the size of an atom from the nucleus to the outer electron shell or the valence electrons. As you go to the right on the periodic table, atomic radii size decreases. As the protons per electron ratio increases, the opposite charges pull the electrons in with greater force. Therefore, according to Coulomb's law, as the force increases, the distance between the nucleus and the valence electrons decrease. Thus, the atomic radii sizes decrease as you go to the right on the periodic table.
I'm Alexa. I'm coming to you from the Amazon rainforest, and today we're going to be talking about electronegativity. Electronegativity is the ability of an atom in a molecule to attract a shared electron to itself.
Fun fact, fluorine is the most electronegative element.
As you go to the right on the periodic table, electronegativity increases. As the radii get smaller, according to Coulomb's law, the distance decreases and the force with which the electrons are pulled into the nucleus is greater. Fluorine is the most electronegative element. As you move to the upper right-hand corner of the periodic table, electronegativity increases. As you go down the periodic table, valence electrons occupy shells that are farther out, thus increasing the distance between the nucleus and the valence electrons. So, according to Coulomb's law, as distance increases, force decreases. As force decreases, the nucleus pulls the bonding electrons in with less force, thus a lower electronegativity. Remember, we do not need to worry about electronegativity for noble gases because noble gases have completed shells and typically do not bond with other elements.
We're on our way to go and see Zena and Alexa in their race to experimentation. Come on, let's go. In the following experiment, you will see 3 alkali metals react with water. We will then explain how this displays the electron shell model.
When you drop solid lithium into liquid water, the result is lithium hydroxide and H2 gas. When you drop solid sodium into liquid water, it produces sodium hydroxide and H2 gas. When you drop solid potassium into liquid water, it produces potassium hydroxide and H2 gas.
In the preceding experiment, the alkali metals, sodium, lithium, and potassium, each have one electron in their outer shell. The oxygen molecule within the H2O compound has 7 electrons in its outer shell. The tendency of electron shells is to complete the 8-electron shell, and therefore the alkali metal gives up its 1 electron to complete the oxygen shell with 8 electrons. During this reaction, hydrogen gas is produced, which creates the... With Coulomb's law, as distance increases, the force decreases. As charge increases, force increases. The electron shell model is defined as the way an atom is composed, with electron orbitals going outwards and the nucleus at the center.
As you go to the right on the periodic table, radius size decreases. As you go down, radius size increases. As you go to the right on the periodic table, ionization energy increases. As you go down, ionization energy decreases. As you go to the right on the periodic table, electronegativity increases. As you go down, electronegativity decreases.
To review the explanations behind the periodic trends, please rewind the video.
Now you're experts.
Now you're experts.
Now you're experts.
Now you're an expert.
Clear as mud?